Hi folks, today we are going to look about the TMS3450NL, a clock found in the many bedside clock radio models. We won't go into much details about this IC as it is identical to the LM8560, which we covered in the previous video and which is in the playlist. I recommend that you watch the complete LM8560 video before you start working with the TMS3450NL, as it is common for the older P-channel MOSFETs datasheets to contain information that can be misleading today. Pay close attention to the VDD and the VSS mnemonics. The setup implemented in the breadboard is exactly the same setup I used to the video about the LM8560. By this reason, I only needed to replace the IC from the breadboard and insert new chip, in this case the TMS3450NL. The pinout is the same and the functions are the same. As you can see in the IC, I proceed with the extension of the pins and convert the SDIP28 to DIP28 because the space or the pitch between the pins in the TMS 3450 is 1.78 millimeters and the space in the breadboard is 2.54. Okay, I'm not received yet the PCB boards to convert the one pitch to another. The clock, after a power fail event, stay with the digits blinking. And to stop this blinking is necessary press the button to adjust the hours or the minutes, for example. Okay, in this case I press the hours, but if I press the minutes is the same result. Now I will press minutes, and as you can see the blinking stopped. As I mentioned at the beginning, we won't dedicate more time to the TMS3450. Instead, we will focus on the common element, the dual LED display. Due to the method used to bias them together with the TMS3450, these displays often deteriorated. Sometimes the first set of the LEDs burn out, sometimes the second. Since the LEDs are implemented directly on the display printed circuit board itself, without encapsulation, replacing them becomes a bit more complicated. We will try to demonstrate that it is still possible to recover the display, and since the goal is to demonstrate what we can achieve, I used green, yellow and red LED LEDs, SMD. Of course, the result isn't perfect, but the idea remains, and you can construct yourself the sets of the LEDs to construct the segments. I need to open the display because it's broken, and to open display I need to cut this small white points and okay. It's open. and you can see the LEDs, or the group of LEDs, is implemented over the PCB, okay? As you can see, I need to replace a lot of diodes, because you can see here the diode itself is implemented over the PCB, the layer of the PCB. And I need to replace 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, a lot of diodes. You can see in the panel the positions I need to implement a new diode. I not clean the resin, because the lead wires of the diode can be broken easily, okay? It's not a good idea clean the surface. I apply different diodes You see I have a red and green again, red and green. But the idea is proof is possible recover the panel. If you apply small SMD LEDs, okay.